Is the era of American rocket dominance already over? I mean, think about it. For the last decade, we've essentially watched a monopoly unfold in the skies, totally defined by the United States and the unbelievable success of reusable rockets. But the era of single-use rockets is officially dead, and a massive, rapid global shift is underway right now. International competitors aren't just trying to catch up anymore, they're actually forging entirely new, highly innovative paths to space.
Welcome to this explainer. Today, we're unpacking a really high-stakes technological sprint. We're looking at the global race for reusable rockets, analyzing how nations all across the world are tackling the monumental engineering challenge of launching a vehicle into orbit and then bringing it back down in one piece to fly again. We're talking cheaper, faster, and infinitely more accessible spaceflight. Here's how we're breaking things down today. First, the reusability revolution. Second, the current leaders. Third, Europe and Japan team up. Fourth, India's winged approach. And finally, the future space economy. Let's get right into it. Section 1. The Reusability Revolution. Why mastering this hardware is suddenly a global imperative. Take a look at this quote from General B. Chance Saltzman of the U.S. Space Force. He points out that China's investments represent an inflection point that could actually result in them overtaking U.S. leadership. So what does this tell us? It tells us this isn't just about cool science anymore. There are intense geopolitical and military stakes driving this technology forward at absolute breakneck speed. Moving right along to Section 2, the current leaders. Let's look at the reigning champ versus the fastest rising challenger. Okay, we absolutely have to start by acknowledging the sheer scale of the United States' current dominance, specifically through SpaceX. Just look at this number. 165. It's honestly staggering. That is the number of orbital missions SpaceX pulled off in 2025 alone, largely using the partially reusable Falcon 9. This blistering launch cadence is, for sure, the gold standard that everyone else is currently measuring themselves against.
But here is where the story gets really interesting. China isn't just copying the US playbook. They're literally forging entirely new engineering paths. So while the US relies on things like landing legs for the Falcon 9 or those giant mechanical catching arms for Starship, China's state-owned Long March 10B successfully completed a test in July 2026 using giant CNETs on floating platforms. The rocket came down and was snagged by this wild four-hook capture system. It's a completely different answer to the exact same engineering problem.
And hey, it's not just the Chinese government pulling this off. Beijing has spent the last decade aggressively encouraging private capital, and now we're seeing companies like Landspace developing the Zhuke-3. This thing is a stainless steel vertical takeoff and landing beast, designed to fly its main stage right back to Earth. While they're still perfecting their landing hops, the speed of innovation in China's private sector is absolutely pushing the boundaries of the global market.
So if we look at the big picture on this scorecard, you can see exactly where the major players stand today. The US has mature operational systems, China is rapidly advancing through testing and that unique sea recovery. And meanwhile, you've got Europe, Japan, and India actively advancing very unique prototype programs to secure their own place in orbit.
Which brings us to Section 3, Europe and Japan team up. Let's talk about the Callisto project. Meet Callisto. It's a bit of a mouthful, but it stands for Cooperative Action Leading to Launcher Innovation in Stage Tossback Operations. Basically, it's a highly strategic three-nation alliance between the space agencies of France, Germany, and Japan. Instead of working in silos, they're pooling their resources and know-how to build and test a single-stage rocket capable of vertical launch and landing. Now, the absolute beating heart of Europe's effort is the Prometheus engine, which is going to power their main demonstrator vehicle, Themis. Prometheus is a total game changer. It runs on liquid oxygen and methane, which is crucial because it avoids soot buildup, something you definitely need for easy reuse. It's extensively 3D printed to speed up manufacturing, features variable thrust, and the best part? It costs literally 1/10 of what the previous generation engine did. And get this, the hardware is already proving itself in a big way. Back in June 2025, a prototype of this Prometheus engine managed 4 successive ignitions in a single day in France. That's a massive first for Europe for an engine of this scale. It proves that this new, ultra-low-cost hardware isn't just powerful on paper. It's highly reliable and genuinely reusable. Next up, Section 4, India's winged approach. Let's look at the Pushpak spaceplane. So while the USA, China, and Europe are all betting heavily on vertical propulsive landings, firing engines at the very last second to touch down on legs or giant nets, India is taking a totally different approach. They're going horizontal. Their reusable vehicle, called Pushback, actually uses aerodynamic wings to glide back down to Earth and land on a runway, much like a traditional airplane or the old US space shuttle. And they are making some serious strides. Just look at the LEX-03 mission from June 2024. They dropped this craft autonomously from an Air Force helicopter at an altitude of 4.5 kilometers. It was intentionally subjected to severe winds and a massive 500-meter cross-range deviation just to test its navigation systems. Well, it autonomously corrected its course and glided to a highly precise runway landing at over 320 kilometers per hour. And the most mind-blowing part? India reused the exact same pushback vehicle from their previous test without a single modification. They proved actual practical reuse.
Finally, let's bring it all together in Section 5, the future space economy.
If you want to grasp the sheer momentum here, just look at this timeline. It's honestly unprecedented. In June 2024, India nails their autonomous runway landing. Exactly a year later, Europe's Prometheus engine fires 4 times in a single day. Then, fast forward to July 2026, and in the span of just 24 hours, China recovers a rocket in a CNET, and Japan completes a highly successful vertical hop test of their RVX prototype. This technology has accelerated worldwide at a pace we've never seen before. So, what does this all mean? Why are all these countries racing so hard? Well, it boils down to this number, 80%. That is the holy grail everyone is chasing. By recovering and reusing these massively expensive first stages, agencies and private companies estimate they can slash the cost of spaceflight by up to 80%. We are talking about turning space travel from a rare, multi-million-dollar boutique operation into a standard, frequent logistical network. That is going to fundamentally alter the global economy. Which leaves us with a pretty fascinating reality to ponder as we wrap up this explainer. We've seen the US dominance, China's rapid and really unique innovations, the strategic European and Japanese alliance, and India's winged ingenuity. As this technology matures and launch costs absolutely plummet worldwide, who is ultimately going to claim the orbital economy? Are we looking at a permanent monopoly or a vastly democratized yet fiercely competitive future in the cosmos? Thank you so much for joining me for this explainer. I'll see you next time.